My name is Sadie DiMaggio, and this is my presentation on hydrophilic and hydrophobic substances and how they interact with water. So, first off, I go through the terms that I will be using a lot. Hydrophilic is pretty much just stating that it has the tendency to mix, dissolve, and be wetted by water. So it has the ability to become wet. Hydrophobic is has the tendency to repel or fail to mix with the given substance, therefore water. So pretty much saying unable to get wet. Molecules, not that big of a deal, but that it's just a group of atoms being bonded together. Polar is having electrical or magnetic polarity. So if you remember, opposites attract, therefore batteries, positive and negative, they will attract. Polar gives it that ability to do that. Nonpolar, being opposite, has no separation of charge, so no positive or negative poles are even there to attract anything or to not attract. It's just alike charges repel. If you remember that, that'll help out. Polar solvents is pretty much my way of saying water. So I will be using that a little bit, maybe once or twice. It's not that big of a deal. As far as hydrophilic molecules, they basically are polar compounds that have ionic groups, and that doesn't make too much sense. So I'll just say the polar nature of these hydrophilic molecules enables them to readily absorb water and eventually dissolve in the given polar substance. Some examples for that is salt and soap, and they will dissolve. We all know they will dissolve into water when put together. Hydrophobic, being opposite, their molecules are insoluble by water, being that almost all of their atoms are uncharged and nonpolar. Therefore, cannot form energetically favorable interactions with water molecules. Some examples of that is oils and fat. As we all know, they will not mix. If we were to put hydrophilic molecules and hydrophobic molecules into a beaker of water, pretty much, if you think of it, philic and phobic, philic being the love or attraction, and phobic being fear or, the repellent of water. So the molecules, for hydrophilic, the molecules will pretty much attract and practically distribute to areas of low concentration, therefore allowing more water molecules to interact and just mix together and get that going. Hydrophobic will kind of just stay in its own little bubble and not want any of that. It'll just say, or if you think of it back in like middle school or elementary school, if you ever did that experiment with your teacher, where you mix oil and water, it just won't. No matter how many days you let it sit, it'll just stay separated like that, and that is why. So oil is a hydrophobic substance, and that explains the separation. I included that hydrophobic is nonpolar, therefore does not produce a static electric field. I didn't go into too much detail with that because it'll be a little bit too long, but I still wanted to include it if you want to do your own research. As far as this photo, I kind of just had to think in my head how this would look if we were to look under a microscope. So at first I started off with, okay, water is polar. Let me write that down, or let me draw it. So if you dig a little deeper, that is why they attract to each other and can mix and attract, and do that. It's because of the hydrogen bonds. And then for hydrophobic nonpolar molecules, they group together in water because the water molecules form hydrogen bonds with one another. So that's pretty much, I kind of drew it as it kind of just stays in its own little bubble, has that lining around it to just repel the water from sticking to it, and just kind of kept in its own little thing. So I hope that I kind of explained it in a comprehensible way. If you don't know anything about this, I didn't know anything about this, so I think that how I worded it and organized it is a nice way to go down and to kind of piece it all together. So I hope that you learned something, and I hope that this explained it all very well for you and not too complicated. Thank you for listening, and I hope you have a good day.